Think about it. You do this dozens, maybe hundreds of times a day. You type a web address, you hit that one little key, and poof, a web page just appears. But it's not magic. It's actually a lightning-fast, incredibly complex chain of events. So let's pull back the curtain and see what's really going on under the hood.
We're going to trace the entire journey of that single key press. The whole thing. From the tip of your finger, deep inside your computer, zipping across the globe, and all the way back to your screen as it transforms that simple command into a fully rendered web page.
You might think our story starts out there, on the internet, but it actually begins right here, right under your fingertips. The very first step is turning that physical push into a signal your computer can actually understand.
And it's kind of wild how different keyboards get the same job done. With a physical keyboard, when you press Enter, you're literally closing a tiny electrical circuit. The keyboard's little brain detects this, makes sure you didn't just accidentally bump it, and turns it into a digital code. On a virtual keyboard, though, your finger actually draws a tiny bit of electricity from the screen, which a controller registers. So, two totally different methods, but they both end up with the exact same result, a digital signal ready for the operating system.
Okay, so that signal gets passed up to the big boss, the operating system. And each OS has its own way of listening. Windows gets a key down message. On a Mac, it's a key down event. On Linux, it's a server event. The names are all different, but the job is exactly the same. The OS acts like this amazing universal translator, taking that raw signal from the hardware and turning it into a command that an app, like your browser, can finally understand.
And now, the browser gets the signal. This is where the mission really begins. It's just been told, hey, go get whatever is at google.com, but before it can go anywhere, it has to figure out what that name really means and where in the world to find it.
Here's the thing. The internet doesn't really work with names like google.com. It speaks in numbers, specifically IP addresses. So the browser's first major task is to find the right phone number for the website it wants to call.
And that's where something called the DNS, or the domain name system, comes into play. The easiest way to think about it is as the internet's giant global phone book. Its entire job is to look up the name you gave it and find the matching numerical IP address.
Now, your browser is smart. It's not going to make a long-distance call if it doesn't have to. It starts local. First, it checks its own short-term memory, its cache, to see if you've been to that site recently. No luck? Okay. It'll ask the operating system, which has its own cache. Still nothing? Then it asks your router. And finally, if all else fails, it asks your internet service provider. This whole cascade just makes sure the answer is found as fast as humanly, or I guess digitally, possible.
All right, so the browser has the IP address. We know where we're going, but you can't just barge in. The next step is to open up a reliable, and this is really important, a totally private line of communication with the server at that address.
First things first, we need a stable connection. This is done with something called the TCP three-way handshake, and honestly, it's just like a super polite, super fast greeting. Your computer sends a little SYN packet saying, hey, you there? Can we talk? The server replies with a SYN-ACK, which basically means, yep, I hear you and I'm ready to talk too. Then your computer sends back one last ACK to say, awesome, the line is open.
But a stable connection is one thing. In today's world, it absolutely has to be a private one too, right? We need to make sure that nobody can listen in on the conversation between your browser and the server.
And that security is handled by another handshake, the TLS handshake. It's kind of like a secret agent meeting. Your browser says hello, and the server shows its ID. That's its public certificate. Your browser then checks that ID with a trusted authority to make sure the server is who it claims to be. Once everyone's legit, they use that certificate to secretly agree on a brand new encryption key that only the two of them will use for this conversation.
Okay, the line is open, it's stable, and most importantly, it's secure. Finally, after all that setup, your browser can actually make its request and ask for the web page.
And you know what's kind of funny? After all that complex setup, the actual request is ridiculously simple. It's basically just a little text message. It says get, which is what it wants to do, a slash, which means give me the main page, and it states the host it's talking to. That's pretty much it. A simple, direct request.
So the server gets this little get message and goes to work. If everything's good to go, it sends back the famous 200 OK code and starts beaming over the web page's data. Or if it's really smart, it might see that your browser already has a recent copy and just send back a 304 not modified. That's basically the server saying, you're good, just use the one you already have. Saves a ton of time and data.
All right, we're on the home stretch now. The browser has received all these raw materials from the server. Now it's time to put on its hard hat and act like a construction worker, taking these piles of code and building them into the living, breathing web page you see on your screen.
So what are those raw materials? Well, it's mainly three things. You've got HTML, which is like the skeleton of the page, the basic structure. Then you have CSS, which is all the style, the paint, the furniture, the design. And finally, JavaScript, which provides the interactivity. That's the brains of the operation.
Then the browser puts all this stuff through what's called its rendering pipeline. It's a fascinating process. First, it reads the HTML to build a map of all the content called the DOM tree. While it's doing that, it's also figuring out all the styles from the CSS. It then mashes those two things together into a render tree. From there, it calculates the exact size and position of every single thing on the page. And the very last step is to paint, where it finally actually draws the pixels onto your screen.
And here is the part that just blows my mind every single time I think about it. That entire ridiculously complex process we just walked through, from your finger hitting a key to signals flying around the world to a server responding and your browser building a page from scratch, all of it happens on a decent connection in less than half a second.
It really is like a high-speed digital ballet, isn't it? A perfectly choreographed dance of data unfolding across the globe, all to deliver the web to your screen in literally the blink of an eye, all kicked off by that one simple press of a key.
So the next time you go to a website and you pressed enter, maybe just for a split second, you'll think about that incredible journey you just set in motion. And it really makes you wonder, right? If all of that is happening with just one click, what other digital miracles are we completely overlooking every single day?